Hello everyone, welcome to Code and Learn. The release of Go 1.24 is around the corner. In this video, I will cover what's new and what has changed with Go 1.24. So let's get started. This version of Go brings generic type analysis. This is one of the highlights of this version. If you want to disable generic type analysis, you can use Go experiment, normalize type params, environment variable. So what exactly is a type alias? Let us first understand a type definition. So what is a type definition? A type definition, like we have arrays where we are creating a new type out of int or deriving a new type out of int, creates a new distinct type based on existing one. This allows you to add behavior to the new type by defining its methods. So here I can then define a method valid on age, which returns a bool if the age is valid or if age is between the given values. This type will still work wherever there is int, which is the parent type, but if the parent type has method, you cannot access them on the derived type. Now let's move on to type alias. A type alias provides an alternate name for an existing type without creating a new distinct type. So here we are creating a type alias. That is, age is now a alias for int. The compiler treats alias and the original type as interchangeable. Type aliases enhance code readability and simplify refactoring, especially when dealing with long and complex type names. Unlike type definition, with type alias, you cannot define a method on it. In previous version of Go, type alias couldn't be used with generic types. However, with Go 1.24, you can do so. So here, we have created a generic type list. Now, with Go 1.24, you can create a generic type alias like we have here. I find this useful when doing refactoring or moving types from an old package to new package. I see this as a great feature enhancement. Next we have tools. Starting version 1.24, you can now add tool directives directly to your Go mod. So something like this, where we are adding a tool stringer using a tool directive in the Go mod directly. You can also add directive for multiple tools like we do for dependencies of the project. So these are some of the new commands that you can use. To add a tool, you can just do go get like you do with regular dependencies. But if you supply a tool flag, it will add a tool directive to your Go mod file, similar to what you can do manually. With this, the Go community won't have to use tools.go and scripts to maintain their dev tools and use them. To run a tool, you can just do go tools stringer, where stringer is a tool that we installed in our Go mod. In case of conflicts between the tool name, you must specify the full path. So something like github/something/stringer. To update all your tools, you can just do go get -u tool and that will update all your tools. You can also install all the tools in your Go bin using go install tools. And then finally, you can list them using go tool to see what tools have you installed in your project. Another great feature added to Go 1.24 is the omit0 JSON tag. So now, when marshalling a struct field with new omit0 option in the struct field tag, it will be omitted if the value is 0. Also note that if the field type has a if0 method returning a bool indicating if it's a 0 value or not, that will be used to determine whether the value is 0 or not. So on your own type, you can create is 0 to indicate if the value is 0 or not. The omit0 tag is clearer and less error prone than omit_empty when the intent is to omit 0 values. So here in our example, you can see we have a struct bar which has field A and B. Both of them are time.time. For A, we have omit0 tag and for B, we have omit_empty. You will see with version 1.24, A is not printed because since we are not initializing any value, it's treated as the 0 value. Before version 1.24, you will see A and B both printed. If you specify both the omit0 and omit_empty tags, the field will be skipped if it's 0 or if it's empty. Next, we have the os.root type. The os.root type enables developer to perform file system operation within a specific directory. The function openRoot exported from the OS package opens the directory and returns the os root type. Methods on os.root operates within the directory and prevents paths that refer to location outside of it, including those that follow symbolic links outside the directory. With this, you can no longer access directory or path outside the current working directory, that is os.root. This improves the overall security posture of visiting directories. Benchmarks can now utilize the p.loop method for faster and less error-prone benchmark iteration in place of looping with for-range testing.b.n. This method offers advantages such as the benchmark function executes exactly once per count, so expensive setup and cleanup steps are now performed only once. Function call parameters and results are kept alive, preventing the compiler from completely optimizing away the loop body. Coming to the strings package, different functions have been added to return iterators, which was a feature introduced in the previous version of Go. For example, lines returns a iterator over the new line terminated lines in string S. Similarly, split sequence returns a iterator over all substrings of S separated by the separator. Then we have split after sequence, which returns a iterator over a substring of S split after each instance of separator. Fields sequence returns a iterator over substrings of S split around runs of whitespace characters. Then we have fields function sequence, which returns a iterator over substrings of S split around the Unicode code point satisfying f of c. Similar to the strings package, multiple functions have been added to the bytes package that return an iterator that can then be ranged upon. Similar to string, we have lines, which returns the iterator over a new line terminated line in byte slice S. Then we have split sequence, split after sequence, field sequence, and field func sequence, which is what we also have in strings package. Another interesting addition is the weak package. The weak package provides a weak pointer type, which allows you to create weak pointers, which is a low-level primitive that enables the creation of memory-efficient structures. Examples of such structures include weak maps for associating values, canonicalizing maps for anything not covered by unique package, and various types of cache. To support these use cases, 1.24 also provides runtime.addCleanup and maphash.comparable functions. Multiple new packages that implement new hashing algorithms have been added to the crypto package. These packages are ML, KEM. Similar to this, we also have HKDF, which is a HMAC-based extract and expand key derivation function. Then we have PBKDF2 that implements a password-based key derivation function. The SHA-3 package implements the SHA-3 hash function shake and cshake as defined in the FIPS 202, making it FIPS compliant. Then we have the text function that can be used to generate random strings, which are very often used in different cryptographic functions. Go 1.24 also introduces two new interfaces to the encoding package. These interfaces are text appender and binary appender. These interfaces append the textual or binary representation of object to a byte slice, similar to the two interfaces before, which are text marshaller and binary marshaller, but without allocating a new slice each time. These interfaces are now implemented by standard lib types that already implemented text marshaller and binary marshaller. So if you check the change docs, a lot of the changes introduced in 1.24 are related to this interface. This enhancement provides a more efficient way to append encoded data to a byte slice, reducing the memory allocation and improving performance. We also have the testing.syncTest package, which provides support for testing concurrent code. So if you write a lot of concurrent code, this would be a great feature for you to try. The syncTest.run function starts a group of coroutines in an isolated bubble, where time package functions operate on a fake clock. Then we have the syncTest.wait function, which waits for all coroutines in the current bubble to block. Again, keep in mind that syncTest package is experimental and requires setting GoExperimental environment variable to syncTest at build time. Coming to the net HTTP package, transport and server now have HTTP2 field that can be used to configure HTTP2 protocol settings. These changes offer developers more control over HTTP settings when working with HTTP2 connections. Great news for fan of WebAssembly. The Go::wasm export directive enables Go programs to export function to WebAssembly host, allowing the Go code to be called from JavaScript or other WebAssembly modules. These changes enhance WebAssembly support in Go, making it easier to integrate Go code in WebAssembly environment. In package testing, the new context method defined on T and B returns a context that's cancelled after test completes and before test cleanup function run. So if you were doing something like this, that is creating a cancelable context, then cancelling it on cleanup, this is no longer required. what you can simply do is get the context from testing.t or testing.b. There is also the new chtr method that can be used to change the working directory for the duration of test or benchmark. Changes to the go command include the go build and the go install commands now support a JSON flag that reports the build output and failures as a structured JSON. Then the go test JSON now reports build output and failures in JSON, interleaved with test results in JSON. Two new major changes for CGO enabled go build are the CGO no escape attribute informs the compiler that memory passed to C function doesn't escape to the heap. This can allow the compiler to generate more efficient code as it doesn't need to worry about possibility of the C function storing the pointer and using it later. Similar to this, we have the CGO no callback attribute, which tells the compiler that the C function won't call back into the go function. This enables the compiler to optimize calls to the C function as it doesn't need to set up stack frame for potential callback. Changes to runtime include a new built-in map implementation based on Swiss table, making it more performant. Then we have the new memory efficient allocation of small objects. Then a new implementation of runtime internal mutex. These and all other performance enhancements made to Go 124 can lead up to 2 to 3% of decreased CPU overheads. These new features can be disabled by using the Go experiment environment variable. Along with all these new features, Go 124 adds support for rangeover function and rangeover end in the text template package. And then we also have improved performance for sync.map. All these features and new additions make Go 1.24 an exciting new release. I would love to hear in comments what you think about this release and the features. Thanks for watching the video. I hope you enjoyed it. Happy coding.